Okay, guys, good morning, all. See, now today we are going to study some of the data structures. Okay, so here in the data structures, we do have the data structure at the end of both sides. Okay, at the server side and at the client side, how it is going to be get useful. So you already have studied item normalization process. Okay, item normalization process, in the unit 1 you have studied how it is going to consider your information whenever you will put it into the address bar, and for the information further document file is going to be get created. In this document file, here is a role of data structure. Okay, here it plays a key role of data structure as a document manager. Here we will have an original document file. Original document file is nothing but the file which is available at the server end. Okay, all the data, okay, from different sources which is going to be available at the server end, that is called as the original document file. And for managing that original data to be get available to the browsing end or at to the client or at to the host, it is obtaining with the help of document manager. So this is nothing but the original document file is a file at the server end. Okay, whatever the original data is going to be there, for that it is available. Secondly, here we are having is nothing but a processing token search file. So this is the second category of the data structure, processing token search file. Means whatever the user will enter the query, okay, so that is going to be get noted, and for that it will say processing token search file. Okay, so document search manager is available over here to handle this task, and this is for the original means at the server end which is the data is available, that is called as original document file. And whatever the query the client will enter, that is called as a processing token search file. Means that information is also going to be get maintained, your queries, your terms, your concept, whatever you will throw from the system end, so that is also going to be get maintained. So at that time document search manager plays a key roles, and the tokens will be available at the processing token searchable file. These are the data store or databases. Okay, this a symbol shows about the data. So to handle the input from the client, it comes in this track, and it is called as processing token search file, where document search manager will be available to handle this file. Okay, and this is the original data. So here we are in this unit, we are learning various data structures such as steaming algorithm, porter steamer. We are learning pat, that is called as a patrica tree, or we are learning signature file or inverted index. So these are the various types of the algorithms that we are going to learn over here. So that is associated with this searching process, not with the originality. Okay, so the data structures that we are going to learn in this some algorithms, so those are associated with this searching process. Whenever the user fire a query, okay, so for that sake his information is going to be get for that document file is going to be get created, and document search manager will manage all its processing tokens. So how the process is going to be get handled, for that sake it algorithms are available. So we today we will see the porter algorithm. Okay, so in the streaming, okay, so in streaming we will have 2 to 3 types of algorithm streaming process. Okay, so that is streaming. What is streaming actually? You should know what is streaming. Okay, and what is the importance of this process. Okay, so streaming is one of the approach, okay, to reduce the size of your search. Okay, you may fire the query which will have some of the meaningless information. Okay, so certain meaningless information is going to be get removed. For that sake, we are going to use the streaming algorithms. Okay, so that we should able to get minimum storage should be get used. Okay, and the processing power as well as the speed should be get increased. So for that sake we do apply here streaming algorithm. Nowadays hardwares are available with a very good features, like memory is tremendous, so we can it is not that much that the streaming is very useful, but it is definitely going to improvement, showing the improvement in terms of recall and precision. So recall is going to be increased, means the see here, streaming is now being received for the potential improvements it can make in recall versus its associated decline in precision. As huge data is there, okay, the search which you are inserted for that also, if you see there can be 10 pages or 50 pages or 100 pages. Okay, so like that if you google, if you do oh, it is going to increasing. Okay, after one page also there will be 15 suppose links, after that also you can able to see number of links which is associated with that information. So recall is going to increase, but precision is going to reduce. So this precision and recall, these terms we have seen in the first unit only. Okay, what is precision and recall? So the degree of correctness of the information. Okay, so these are, that is called as the recall. Okay, recall and precision terms. So why do we are using the streaming? Streaming is used mainly to reduce the storage space and to increase the processing speed, so as the faster recovery or faster query answer should be get available to the client. For that sake we do use this streaming algorithm. In this streaming algorithm, the most what we can say popular algorithm is nothing but the Porter streamer algorithm. Which is the popular algorithm? Porter streamer algorithm. So before to that, whatever the streamer technique that we are going to apply, we do have a suffix streamer, or we do have a dictionary lookup streamer, or another variety of the streamer. So in that, streaming means what? We are going to make short, removing some of the extra irrelevant characters from the word, that is called as streaming. Okay, so if we are applying that, it means that the leftover word which is going to have to us, it should be correct word. Okay, so there are two constraints of the correctness, that is the overstreaming and understreaming. Overstreaming means you have removed too much of the alphabets or characters of a word. So that is called as overstreaming. Too much of a term is removed. That is called as overstreaming. And understreaming means very few alphabets has been removed. That is called as understreaming. So as we discussed, it is going to give the facility of increasing recall, but precision is going to decline. And definitely with this approach, the speed is going to increase and the size of the storage is going to be get reduced. And we will get the compression performance, means as we are reducing the particular words into some size, so performance is going to be get increased. So various algorithms are available over there for performing this type of the streaming. Streaming means removing the extra alphabets which are not that much useful. So for that, conflation technique is there, manual is there, automatic is there, n-gram is there, affix removal is there, successor variety is there, table lookup is there, longest match and simple removal. So these are the types of stream algorithm. Okay. Have a look at this. What are the types of streaming algorithm? Out of that, some of the streaming algorithm we are going to cover. Okay. So manual, automatic, n-gram, affix removal, successor, table lookup, longest match and the simple remover. So these are the some of the streaming algorithm that we are having. Okay. Is it fine? So we directly go to the Porter steamer. Okay, so Porter steamer. Okay, so how does this Porter steamer will work? How does this algorithm is going to work? So this Porter steamer is nothing but the name of the algorithm, which is having certain actions and step on which it is going to work. Okay, so in this Porter steamer, certain logic is going to be get applied. So it is this algorithm is totally based on to the morphological concept, or we can call on to the semantic based concept. So in affix removal algorithm, we are going to remove the suffix or prefix. Okay, we are going to remove the suffixes or prefix. So suppose if any particular word ends, okay, okay. So if any particular ends in IES, okay, IES, but not with EIES or AIES, then it is going to substitute it with Y. So this is the one of the rule of affix removal algorithm. If it is ending with IES, it will replace it with Y. If any word is ending with ES, it will replace it with E. Okay, but not like this type of the concept is not going to be get considered AES or EES or OES. And if the a word ends with S, if any word is going to have S, so it will not consider that as represent it with null. Only there are two exceptions if it is us and ss. Okay, okay, these are the two exceptions. If the word is ending with s but it is having u also besides to it, or ss combination, then that time it will not represent n, null. Otherwise it will be null. Okay, so these are the some rules, okay, for affix removal algorithm. Okay, so IES it will form into Y, ES into E, and as to null. And these are the some of the exceptions when these rules are not going to be get applicable. So our portal remover, the most popular algorithm, it will come in your exam probably. So portal algorithm is an affix removal algorithm, which is going to based on to certain conditions on the stems. Okay, stem is nothing but the your word is going to be there, the word last endings, okay, or either the beginning information, that is called as the stem. So we do follow certain rules for that. So there are certain conditions on the stems, on the suffix, and on the rules. So look at here, what is the condition on the stem specifies. Okay, condition on the stem. So what it is showing here is the measure denoted m of an atom is based on the alternative vowel consonant. You know what are the vowels? A, E, I, O, U. These are called as the vowels. Okay, and consonant means apart from A, E, I, O, U, those are called as the consonants. So here we are going to have consonant, vowel, consonant to the degree of m. Okay, degree of m means how many times it is repeating. VC means combination of vowel and a consonant in a given word, how many times it is repeating. So m can be 0, or it can be 1, or it can be 2. It means that a number of the times the vowel consonants are appearing in the particular word, and this is showing here V. Okay, so consonant, vowel, consonant to the power of m, V. Okay. So how to identify this M? Okay, how to identify this M? If suppose, for example, now we are having certain words. Okay, so when it is called as M equals to 0, or when it is called as M equals to 1, or when it is called as M equals to 2. So as I discussed, V stands for vowel, C stands for consonants. So we are nothing but only five are there: A, E, I, O, U. So we need to check, because on this again further some rules are going to be there. So we need to check vowel and consonant, how many times it has been appeared, a combination of vowel and consonant in a word. So we look for the vowel. Do we have here any vowel? No. Here, do we have? Yes, we will have, but after that consonant is not there, right? Again here we'll see vowel is here, but after that consonant is not there. We don't have here any vowel, so that's why M equals to 0. We did not found any in this, any of the words in this row, any combination of vowel and consonant used together. Just after the vowel, consonant is not used in this term. That's why we will say M is equals to 0. Okay, now M equals to 1. Now again few examples of the words has been given. Okay, so look at where vowel is there. Yeah, here we are having the vowel, but after that we are having another vowel, right? But it is okay. We forget about this O, E. So this is what vowel is there and consonant is there. So 1 degree of M equals to 1 we achieved here at the UB. Okay. So M equals to 1. After that, here again you are not getting. Okay. After this consonant, you don't have the immediate vowel. So here we are getting at combination of vowel and consonant. Again look at here, oats word. So this is a vowel, but after that we are getting AT. This is a vowel, this is a consonant. So we are getting combination of vowel and consonant only once in this word. So M is 1. Okay. Same here. Here we are having E, but we need a combination of VC. So ES. Okay. This is a V and this is S. So one time it is appearing. So M equals to 1. IVY. Okay. So I is vowel and V is a consonant. So one time. So degree is M equals to 1. Okay. So like this. Now it is going to increase. M equals to 0, 1, 2, 3, like that. Okay. So M equals to 2. So in a particular word, now you find out how many times the combination of vowel and consonant appear together. Here we are not getting, here we are getting 1. Okay, UB. Okay. And here you see ES. Right. So 2 times we are getting vowel, consonant, vowel, consonant. Am I right? So M equals to 2. Next again, here we are getting 1 IV, vowel consonant, and again here we are getting vowel consonant. So 2 times. So M equals to 2. Again here AT we are getting, okay, one combination, second EN, vowel consonant. So this table is specifying you VC. VC means a combination of vowel and consonant, how many times it has been appeared in a particular word, right? Have you understood this? Okay. Now, so this is what the condition on the stem of the measure M. Okay. C VC to the power M V. Now here, what does it mean? A star X. So the any stem ending with a given letter X. Okay. That is called as star X. Here in between it is representing V means vowel. So the stem, any stem contains a vowel. Here there is a certain words that will have a double consonant uses. Okay. So the stem ends in a double consonant. Any consonant which is appearing twice, many times double S will appear, right? So that is called as double consonant ending. Here a star O. What is the meaning of this star O? Indicates that a combination of consonant, vowel and consonant. Okay. It is called as a combination of consonant, vowel and consonant sequence. But as we said, vowel consonant, consonant, vowel, consonant. This last consonant should not be W, X or Y. Okay. Okay. So this last consonant should not be W, X or Y. So the porter steamer will follow these conditions and some rules to be get applicable. So step 1 for the word, and then it is coming for step 1B, step 1C, step 2, step like this. Some steps are there. So here you will not understand the steps. We need to see look at again separately. Okay. So step 1 for the word and step 1A, 1B, 1C are there. For the first step, A, B, C is there, and further you do have 2, 3, 4, 5 A and 5B also is there. So fifth step is going to be get again repeated for the stem operation. Okay. Fifth step is going to be get repeated for the stem operation, and step 1 is also 3 times. First step 1A is for word. Step 1B, if the second or third rule of the step 1B was used, then we can go for step 1B1. Intermediate also some step is going to come. So we'll see with example, means you will get more clear how does this stemming will be performed on the words. Okay. So example of the Porter steamer algorithm. Mainly why do we use is to remove the stem. Stem means what? Any word. Now original word is connect. Okay. So we need to obtain its root word. We need to come towards the root word by removing the unnecessary um, alphabets. So that is called as a stemming. So if we are having the word connected or connecting or connection or okay, screen is visible to everyone. Hello.
No, ma'am.
No.
Yes, ma'am.
Yes or no? Uh,
Yes, ma'am.
Ma'am.
uh, okay. Yeah. uh, so we are coming to the root words. Okay, so connect is the root word, and if we I mean to say, if we are going to have certain words which is ending with ed or ing or ion or ions, so as to reduce the memory, we are removing these extra alphabets and forming its root word. Okay, so this happens at the searching process internally. Next is the same, this is nothing but the Porter steamer algorithm. Okay, so why do we use this? Is for forming the root of the word. So we can define it as stemming is the process of reducing terms to their roots. Okay, it is nothing but the process of reducing terms to their roots before indexing. Okay, so streaming, now as we said, affix streaming. So it is language dependent. So any words which are going, this is one more example, like automates or automatic or automation is there, so we are going to form the automat. Okay, so like this means it is certain meaningful word, and here we can say the suffix streaming has got applied. So we are removing this extra. Okay, and we are getting the root word as automate. So as we discussed just now, we have a slide of that step 1 to 5 are there. So those are called as the 5 sets of the rule. Okay, those are going to be get applied for particular word. So the Porter steamer algorithm is based on to the concept of consonant and vowel. Consonants and vowel. So as you all know what is vowel and what is consonant. and these also we have seen. um, the words are generally in this protocol. Okay, so consonant, vowel, consonant to the degree, and then again vowel. All we have studied this. Now this one is done. So as we have seen this first part, measure of the word, how to calculate. Okay, then now some rules are going to come. The rules are of the firm condition. Okay, so if the rule is m is greater than 1, m means what? Now here we have seen now what is m. Okay, so if the m is greater than 1, then that time this condition is going to happen. Suppose particular word is there, replacement. Okay, replacement means m is greater than 1 means m is 2. It means a combination of here vowel and consonant. We see, we are saying no, a combination of vowel and consonant appearing two times. Okay, so this is your vowel, this is consonant, again vowel, again consonant. Okay, so we are removing those what I mean to say, letters, and we do get obtained this as a root. Okay, so this is one of the rule for removing a suffix. Okay, so if m is greater than 1 means m is 2 or beyond that, at that time we can able to say represent it with a null. Okay, so nothing after the means if the rule is satisfied, then we should not consider those elements. So these elements we are not going to consider. Like that, the conditions are there. This also we have seen. Hmm. So the Porter Steamer algorithm, step 1A. So if any word is having SS, ES, so it is going to consider it as SS. So this ES is going to be get removed for this example. Okay, if the word is ending with IS, then we are going to have only I. ES is going to be get removed. Look at in this example, ES got removed. ES got removed. If in case the word is SS, it is as it is. Okay. If the word is particular word is ending with S, so we will not consider that S. So dogs, cats, we are removing this and we'll obtain this. So this is the Porter Steamer step 1A. Okay. So as to remove certain alphabets, we have applied these rules. So ending with double SES, it becomes SS. If simple as one single S is there, then at that time it will remove that S and we'll get this word. Now again, some of the rule which will come in the step 1B is if m is greater than 1, as we already discussed, what is m, you know. Okay, so m is greater than 1, and at that time if you get EED combination, then you are going to make it as, okay, D is going to be get removed. Okay, D is going to be get removed, like here also. Okay, so feed is there. So for sometimes it may not be applicable, so that is also condition not verified for this word, but for agreed we are going to remove the D. Now again, for vowel is there in between. Okay, so plastered, so we can able to remove it here, but here it is not going to applicable. So there are some fixed words for that it is not going to applicable. So again, a combination of vowel is going to be there and having the ing, so it should be get removed. This is like null operator. Okay, so ing if it is used, you can write for singing, dancing. Okay, any sort of work for that sake, we can use motoring, suppose, so motor. So at that ing also we are going to remove, so it is 0. Okay, so but there are some particular string or particular word for that it is not applicable. Sing is having its own meaning. If we remove this, so it did not work. The word is going to be get itself losing its root. Okay, so certain condition it is not going to be get considered. uh, now again 1b. So 8 is there, okay, so it is going to consider it as ATE, okay. You can look at this. Troubling, trouble, okay. Like this also some of the conditions are there. Star D means ending with D, okay, and L ending with L, or S or Z single letter, okay. So in that case, if it is there, so one condition falls, hopping, so ending with double T, okay, and I. So we'll write here this thing. So tan, but at certain times it is not going to be get applicable. Fall, if we do consider ending with double, what do we call, star D indicates what, here suppose double consonant, okay. So double consonant if we use, we can able to make it as a single consonant only, single letter can be get used, okay. But for some cases it is not going to be get, it is not applicable, okay. What is this operator indicating? Not applicable for the words ending with L, S and Z, okay. A double consonant situation cannot work for the words ending with L, S or Z. This is a not operator. So double consonant, if we are using here PP and ing, so here I am removing ing and I am as well as removing one consonant. So hop it is going to come. But here it is not applicable for the L. Okay. So if it is L means we need to consider double L only. We can't remove this one L. Hmm? Then M equals to 1 and ending with O is given as empty, okay. So filling, so file, okay. Sorry, this is actual E, we need to consider this E, okay. So at that time if it is a file, M equals to 1, if we are having a degree of M equals to 1 means combination of vowel and consonant is appeared over here one time, okay. Vowel, this is I is vowel and C is consonant, then we can able to remove this extra ing, okay, and we have to take this E, okay. So file, and in some cases the condition fails, okay. So for the word fell, we can't able to add their E at the end. So this is the some of the rule. Then again we can able to replace with I, okay, eliminate step 1C, okay. So if it is having a vowel and then we can able to replace it with I, Y becomes the I, but at certain stage it fails, okay. This condition goes to fails. If again step 2, if M is less than M is greater than 0, okay, then if the particular word is there actional, so we can make it as ATE, okay. So relational, it becomes relate, okay. So if this combination is going to appear ATIONL, then it becomes ATE, so relational becomes the relate. Again, if M is greater than 0, isation becomes the is for a particular word, suppose generalization, specialization, okay, or this word. So ZATION is going to be get eliminated and it becomes from I, it becomes IZE, okay. So generalize. Then there are certain words such as again ability and all, so that time also it is going to remove it, and so like sensibility, it going to consider it as a sensible. So these are all the rules for English words has been considered based on to the morphological occurrence of the particular alphabets and these words has been used so as to obtain the root of your actual word. Again in step 3, ICATE is there, then it is going to convert into IC with a combination of M is greater than 0. Okay, if M is greater than 0 means definitely a combination of vowel consonant should appear once, means it indicates M is greater than 0. So here we are not considering, this is epsilon, this is not E. Okay, this is epsilon means we are not considering, this is acting like a null. Okay, so hopeful is there, one of the word, so we are going to remove the full. Okay, then ness is also going to be removed, entire it is going to remove, so null or epsilon we can say. Now here also it is going to be get removed. So, derivation morphology step 4, m is greater than 0, again for all the condition m is greater than 0, and means a combination there exists of vowel and consonant in a particular word, such as the word allowance. Okay, so ance, if it is ending particular word, then it is going to be get replaced with null, so allowance become allow. Then again e and t also is going to be get null, so depend becomes the dependent become depend. Again IVE becomes null, so effective become effect. So like this, step 3 and step 4 is going to be get calculated for the words. It will check all the words. Okay, then 5, then m is greater than 1, suppose, means more than 1 means more than 2 combinations of vowel and consonants are there, and that time if e is going to be there ending e, so it is going to be get removed. This is epsilon, so e is going to get removed. Okay, same if m equals to 1 and not having the o. Okay, then it is going to uh, remove that term ness, so it becomes empty. Okay, null, so goodness becomes good. Then step 5b, m is greater than 1 and double consonant is there, and letter is having a L. Okay, then it is going to have the what we do call it as it will convert into a single letter. Okay, for some conditions we need to check. So this is the last condition, m is greater than 1, so there is a combination of vowel and consonant appear twice or maybe thrice or as many times more than greater than 1, and there is a double consonant, star d means double consonant, so double L is there and that ending with L. Okay, and also ending with L, so at that time we need to use only single letter. So control, suppose this word, so control, roll. Okay, for this it is not going to give the correctness, so condition not verified. So this is what the portal algorithm here it ended. So it is having these all steps. Okay, so 5 step 1 to 5 it is having, so certain rules are applied so as to obtain the original word. So maximum times it will give correctness, sometimes some words it is not going to give correctness, so condition not verified wherever it is found, so that there is the failure of this algorithm. So mainly this algorithm is going to increase the recall, but precision is going to be not that much. Okay, and time and the processing speed is going to increase, and the storage requirement will be less as we are eliminating the unnecessarily alphabets. Okay, so this is called as a steaming, and this particular algorithm which is following the particular combinations of this step 1 to step whatever 5 we have seen, this particular combinations is nothing but the porter steamer algorithm. Okay, so you can't just write like that in the earlier slide we have seen somewhere. This will not give any meaning. Okay, this may call as an algorithm, but until and unless you will go from step 1 to step 5 with an example, it is not going to be understandable. Okay, so how does this steaming is going to apply for the word? For that the step by step example you need to follow, and that example you need to write in the exam. Okay. So if only definition is asked and what is the importance, then that time you can specify it is one of the data structure used to obtain the actual root word. Okay, by applying steaming or by applying certain conditions or certain rules of affix removal. And algorithm is going to be get asked means you need to write it this one also, and example you write. Okay, so if you write that example and that formula CVCM, what is M? Okay, so some examples you give for that word, so that will give you more weightage, and that steps, these steps you need to tell all these steps 1 to 5. Okay, so any doubt is there in this Porter streamer? All of you understood this algorithm Porter streamer? So this is called as a Porter streamer. I will forward these slides because in books I don't know how much it has given properly and all. So we need to find out it from the various sources, and to give you a proper example, I don't think its example is available in the normal textbook. Okay. How does these steps are going to be get considered? Um, Followed by that, what we can have? One of the concept or one of the algorithm that we can able to apply for this data structure is nothing but called as a signature file structure also, is one of the algorithm. Okay, this is nothing but a search process, normal your search process. In your search process you will be sitting at the front end system and you will fire any query, or you are interested to look for a particular text or for a particular image, so that is called as a search pattern P. Okay, so as we discussed, sorry, hello,
Hello, who is talking?
yes, anyone is having any objection? Hello. Hmm. Okay, fine. So yeah, we'll move because we need to complete the syllabus and we'll have hardly 2 3 classes. So you should able to understand the concept and should write something in the exam if you are going to ask me. Can't sometimes the situation will not be that much good. So try to understand the concept. So let me take this signature file, 2 slides, and then we'll stop. So signature file structure. Okay. So signature file. So as we discussed, being a user, you will fire a query that is nothing but the search pattern. The user is interested to look for a particular text or image or whatever his interest. Okay, so a document database. Okay, your query is going to be get normalized and it is going to be get obtained in this here at the document database. So this is at the server end. Okay, so server end, it creates the index file. Okay, whatever you fire a query, for that query also indexing process is going to be get applied. And if the, and then while searching it, if it is found the match, if whatever the query you have kept and that particular word is available here after checking, then it is going to um, forwarded to the user. Okay, and if it is not available, then it is a it will not return it to the user. A particular pattern is found of your search. If it is available with matching with the index, then the system or the document database or data structure will forward it to over to the client. If it is not available, then it can't able to forward. Okay, so if exists, it will find. Okay, and as the why it is showing here two-way, because depends on the search query or search query whatever you kept. Sometimes if it is not available also, but we can able to understand that right now the clients are keeping such sort of the request, so that particular combinations of the indexing can be get further. It is easy for at the what we can call server end to analyze certain sort of the request and make certain sort of the data available. For that sake also it is going to note the patterns. Okay, so search query patterns, if it is already existing and matching with the database, it will directly make it available to the client. But sometimes your queries is not answerable, then at that time they will note it that these types of the questions are also coming, and the particular professional expertise who are sitting at the server end will definitely try to resolve, or they will try to publish some papers, or like certain data they are going to make it available with that indexing. So for that sake it has been shown as two-way. So actually this concept is going to be based on, suppose if you have entered any text. Okay, your entire text, this is your query suppose. Okay, so it is going to be get divided into blocks. Okay, means a fixed size is allocated to your query. It is going to be get divided into block. What we are discussing about signature file structure. Okay, so words are divided into blocks. Okay, so this is a block 1. Okay, we can call it as a block 1. This is called as a block 2. This is called as a block 3 and block 4. Now for this, whatever these alphabets are there inside the system. Okay, they do represent in a binary form this information. Okay, so for this text, block 1 is going to be, and which will have some fixed binary value. Okay, for this combination of word, it is having suppose this binary value. So these are the system created table. Okay, it it is going to be get automatically created by the system. For this particular text, this block 1 is having this binary value. For this block of word, it is having this binary value. For this block of words, so 4 block of words are going to get certain binary value. Now if you are interested, this is a particular text and a particular pattern need to be get matched. Okay, um, so this is a pattern called as made pattern, whereas this is nothing but the entire document. From that document, if you are interested to search a particular word, made is available in this document or not. If it is available, it will return to you. So consider, this is a very short example. Consider this as a database. Okay, your text, and you are looking for a pattern called as made. Okay, so for your understanding purpose, this concept has been given just to understand it with a small example. So this is a database. In this database, it has been broken into several portions, that is called as blocks, and every block got binary value assigned and it is stored in a separate table. Okay, and so here we can able to see its address is also going to be there. And now I'm interested to look for a particular word. So if that particular word, also every word is going to have its binary value. Okay, so for this it is having this binary value. Now this, with the block 1, it is going to perform the check. Okay, by performing the AND operation. Okay, so by performing the AND operation already you have studied. Okay, so with this combination and this combination, it is going to perform the AND operation. It is checking whether it is matching. No, it is not matching. Now again, AND operation. This HMAD means here AND operation again with this text. Okay, block 2 and this value is ANDed. Block 3 and this value is performing AND operation. Block 4 and this value. In some cases you will get a match, in some cases you may not get a match. Here I got the match 001100, means the particular text is available in this document. Okay, so that document is going to be get available to the user. Information retrieval system, this is the word. Suppose if it is a matching, then it is going to be answerable to the client. Okay, if the block is not found, then it is called as a false drop. This condition is called as a false drop. If the particular word which the client is interested to look for, if it is not available, then it is called as an file. This concept is called as a signature file. Always remember, in signature file we are going to search a particular this is nothing but the entire document or your entire text we can call, or a database you would like to call. It tries to find a particular pattern. For that, indexing is going to be available. Okay, if the particular pattern is available, it will give it to the client. Okay, signature is creating. Signature file is nothing but breaking the text into blocks, and that blocks is going to assign the binary value, that is called as a signature. Okay, signature means what? For a input text, a binary value is going to be get created, and it is going to be get maintained in a separate table, and it is going to perform a match. If the match is found, then it is going to return it to the client. If it is not match, then that also it is going to consider certain queries can be addressable by solving such issues. So entire text is divided into blocks, and block will have a binary value. It is stored separately in a table assigned with some unique address, and then the AND operation of your pattern is going to be get applied with every block of data. If a match is found, then a particular information is retrieved to the user. So this is what called as a signature file. This is also one of the data structure, okay, that is applied for the searching process. Okay, so today we have studied porter streamer, and we have studied signature file. I will forward this document to you. Okay, so you need not have to worry. So by this example you can write it up in your exams. So two concepts we have covered today. Then tomorrow we will see about the your what do we call it as inverted and all. Okay, so this we have covered porter steamer. Now we'll have attendance. Okay, A section, answer your roll call. Today is 16 December. 23, roll number 23. Roll number 23 absent. Next E2, J1, sorry 11. Third CSCA 27, 45.